Kia ora, and welcome to lesson 9 of Maths with Corinne. Today we are looking at solving simultaneous equations. And this, when I was in year 11, was actually my favourite thing that I did in the whole year of maths. So I still quite like simultaneous equations. They're really fun. We're going to today just focus on using the substitution method. So there are two methods that you can use for solving simultaneous equations. We'll start with the substitution method, and on Monday's lesson I will go through the elimination with you guys so that you've got a choice in which one that you can use. The substitution method is good, and I'll go through some exam questions where you can see how it can be used. It's not always going to be the easiest method to use, so just bear that in mind. There are some simultaneous equation sort of questions where it might be a bit more difficult or tricky to use the substitution method. And so it is good to learn both so that you can pick and choose what will suit you depending on what you sort of have in your exam. So simultaneous equation. So in these questions you're solving two equations at the same time, which is why they're called simultaneous equations. And we are doing that to try and find out the value of two variables. So in all of the other equations that we have solved so far, we've only had one variable, one unknown. In this scenario or this situation, we have two variables, two unknowns, often x and y, but it doesn't have to be x and y. It could be whatever letters you choose or whatever letters are given to you. Okay, so for the substitution method, we're actually going to make use of the rearranging formula skill that we looked at in the last lesson. So we need to make, for one equation, one of the variables the subject. Once we've done that, we can then substitute that expression for that variable in your second equation. And the purpose of doing that means that when we simplify, so we might have to expand out some brackets, move some things around, but when we simplify, we only end up with one variable. And often there will be a linear equation that we can solve to find the value for the first variable. Once we know that, we can substitute that in to our original equation in order to find the value for that second variable. Okay, so that's sort of how it works, but probably a lot easier to understand with some examples. So we'll get started. So this is the first example, and the first two examples I'm going to go through today, I've given you the equations. In your assessment, I think you should expect to have to write the equations yourself from the information that's given to you. So you'll hopefully be familiar with lots of contextual questions in algebra papers, and so simultaneous equations is one where you can expect to have to write those equations based on the information that they give you in the question. So these first two examples will just kind of show you how the skill works, and then I've got an example where we'll write the equation, and then we've got some previous exam questions to go through. So for this first example, we know that y is equal to 3x, but we also know that y is equal to 2x minus 7. So if y is equal to both of those two things, then it makes sense that 3x must also be equal to 2x minus 7. Okay, so essentially what we're doing is saying that if y is equal to 3x, then instead of writing y here, we can replace that with 3x because they're equivalent. So we've rewritten this expression, but we have substituted the y with 3x. So now we have a linear equation, and we can solve it for x. So bringing our 2x to the left-hand side, 3x minus 2x gives us x, and we are still left with negative 7. So we already know the value of our first variable, and we can use either of these equations now to solve for y. I'm going to use the top one because it will be faster. So y is equal to 3x, but we know that x is negative 7, so 3 times negative 7 gives us y is equal to negative 21. Okay, and then often it's a good idea just to check. So we know that this equation works because we just used it to find y. So if we check with this one, if x is negative 7, 2 times negative 7 is negative 14. Negative 14 minus 7 gives us negative 21, which is what y is equal to, so that works. Okay, so our two solutions, x is equal to negative 7, y is equal to negative 21. Done. In our second example, this one is a little bit more complex. We've got 2x plus 4y is equal to 2, and then 3x plus 21 is equal to 2y. So at the moment, we don't have either x or y as the subject of either equation. So that's the first thing we're going to need to do. Make either x or y the subject of an equation. It doesn't matter which one we do, but you probably want to be careful about which ones you choose because it will be easier than others. So if we look at the second equation, we've got 3x plus 21 equals 2y. I can divide 3x and 21 by 2, but it will give me a fraction, so that will make things a little bit more difficult. And then likewise, I can divide 21 by 3, but dividing 2 by 3 will give me a fraction. So if we think about this top equation, 2x, 4y, and 2, they're all divisible by 2. So I'm going to rewrite this first equation, and I'm going to divide it through by 2, first of all, so that I get just an x. So when I divide through by 2, I need to make sure that I'm dividing all of the terms in that equation by 2. And then we're going to rearrange it to make x the subject. So if we just label this equation 1 and equation 2, we are going to take equation 1 and divide it by 2. So that gives us 2x divided by 2 is x, 4y divided by 2 is 2y, and 2 divided by 2 is 1. Okay, now rearranging, we want to make x the subject. 1 stays where it is. We're adding 2y on the left-hand side, so we can subtract it, which means we need to do the same thing to the right-hand side. So x is equal to 1 minus 2y. Now we have an expression for x in terms of y. So here, instead of writing x, we're going to replace that with 1 minus 2y because we know that it holds the same value. So we've got 3 of those. So we have 3 lots of x's, which is 3 lots of 1 minus 2y. Plus 21 is equal to 2y. So now we've only got y's. We're going to expand, collect all of our y's on the left-hand side, and solve. So 3 times 1 is 3, and 3 times negative 2y is negative 6y, plus 21 is equal to 2y. 3 plus 21 is 24, so negative 6y plus 24 is equal to 2y. If you want to move your y's to the left and your numbers or your constants to the right, then we need to subtract 2y from negative 6y, so we get negative 8y, and subtract 24 from both sides. Means that we end up with negative 8y is equal to negative 24. Dividing through by negative 8, negative 24 divided by negative 8 is going to give you y is equal to 3, positive 3. Once we know the value of y, we can use this rearranged equation in order to find the value for x. So we know that x is 1 minus 2y, so that's going to be 1 minus 2 times 3, 1 minus 6, which is negative 5. Okay, so our two solutions, y is 3, x is negative 5. Again, you can go back and check. So 2 times negative 5 is negative 10. And 4 times 3 is 12. Negative 10 plus 12 is positive 2. So that works. And then again, check both equations. So 3 times negative 5 is negative 15 plus 21 gives us 6. And then 2 times 3 is 6. So it works for both equations. Good. Okay, so just to recap, for this particular example, we had to divide through by 2 first so that we could get a single x. And then we rearranged to make x the subject of the equation. Okay, so just make sure that when you're looking at these equations, if you're going to use the substitution method, just check which one will be best to divide through by if you have coefficients of either x or y. So third example is a contextual question. So we'll read through the information and then we're going to use that in order to work out our 2 equations and then we'll solve them. So 2 families went to the observatory. The admission fees are $8 for an adult and $2.50 for a child. If there were 14 people who paid a total of $57 in admission fees, how many children and how many adults were there in the 2 families? Okay, so going to the observatory, admission fees are $8 for an adult, that's probably quite important, and $2.50 for a child, that's an adult. $8 and $2.50 for a child. There are 14 people altogether. Okay, so 14 people altogether, and they paid $57 in total, okay, in their admission fees. So from that information, we're going to write our 2 equations. So let's say A is the number of adults and C is the number of children. Some people find it really helpful to spell that out at the start because then we know exactly what it is that we're talking about. So we know that there are 14 people in total. So the number of adults plus the number of children must be 14. It's 14 people in total. The other piece of information we know is that they paid $57 in admission fees, and we know what those admission fees were. So $8 for an adult and $2.50 for a child. So $8 times the number of adults plus $2.50 times the number of children gives us the $57 that they had in admission fees. So now we've got our two equations. We can label them 1 and 2. So A plus C is 14 and 8A plus 2.5C is 57. So making either A or C the subject of an equation, so rearranging the first one is going to be the easiest way to do that. So rearranging equation 1, we just make A the subject. A is equal to 14 minus C. So now, if we know that A is equal to 14 minus C, we can substitute that for A in that second equation. We know that they have the same value. So we've got 8 lots of 14 minus C plus 2.5C equals 57. Okay, 8 lots. So 8 times 14 or 8 times 10 is 80 and 8 times 4 is 32. So 8 times 14 is 112 minus 8C plus 2.5C is equal to 57. So tidying this up, we've got negative 8C plus 2.5C. Well, negative 8C plus 2C would be negative 6. And then plus the 0.5C, we get negative 5.5C. Okay, and 112 is still here on that left-hand side. Okay, bringing the 112 across, we get negative 5.5C is equal to 57 minus 112. So if you subtract 112 from 57, you get negative 55. So C is equal to negative 55 divided by negative 5.5, which happens to be 10, positive 10. Okay, so C is positive 10. So we know so far that there are 10 children. And then if we go back to here, remember A is equal to 14 minus C. So 14 minus 10 means that A is equal to 4. Okay, so 10 plus 4 gives us 14. And then you can check the second one with your substitution if you want to. So the question, just go back and make sure that we have answered it. How many children and how many adults were there? I would always recommend writing a statement at the end of these just to make sure that you have your answer in context. There were 4 adults and 10 children. Okay, so that we have our context in there. Alrighty. So we've got 3 questions to go through from the last 2 years' exams. So I'll go through those with you, and then as usual I'll talk you through the marking schedule for those particular questions. So this first one was from last year's paper. It's all to do with graphs. So it says the diagram below shows a sketch of part of the graph y equals 7 plus x minus 6 squared. Aroha draws another line onto this graph with the equation y equals 8x plus 4. Find the x values of the 2 points where the 2 graphs intersect each other. Okay, so we can see, and I've labelled the graphs for us. The parabola here is the y equals 7 plus x minus 6 squared, and the straight line graph is y equals 8x plus 4, and we want the x values where they intersect. So these x values here. Okay, now they're going to meet when they're equal to each other. So in this case, we're actually given the equations. We just need to solve them in order to find where they're going to intersect. So we've got our 2 equations, and they're both already equal to y. So this is like the first example that we did earlier. So we know that 7 plus x minus 6x squared is equal to 8x plus 4. What's different about this one is that while we only have x's, we've got an x squared. So instead of having a linear equation to solve, we've now got a quadratic to solve. But that's okay, we know how to do those because we covered those in an earlier lesson. So for a quadratic, remember we need to move all of the terms onto one side of the equation. So we make it equal to 0, we factorise, and then we make each factor equal to 0, and that's going to give us the two solutions. Because remember there are two x values. All right. So moving everything to the left, we will have 7 minus 4, which is 3. X minus 8x is negative 7x minus 6x squared is equal to 0. So for a quadratic, when we factorise, typically we write the x squared term first, then the x, then the constant equals 0. The other thing that I'm also going to do, to make it easier for me to factorise, I'm going to multiply everything by negative 1 so that we end up with positive 6x squared. Okay, so it's going to make life easier for me. So 6x squared, negative 7x becomes positive 7x, and positive 3 becomes negative 3 equals 0. And now we need to factorise. So we could try 6x and x, and if we do that, we need negative 3, so we have to have a 3 and a 1, we know that. If we just try this way around, because it's a negative 3, we want to get a difference of 7. 6x times 3 would give us 18x, and 1 doesn't have a difference of 7, so that's not going to work. We could try 6x with 3 and x with 1. 6x times 1 will give us 6, and then 3 also doesn't have a difference of 7, so that's not going to work. So we could try 3x and 2x. Okay, so 3x, if we put our 3 here and our 1 here, 3x times 3 would give us 9x, and then 1x times 2x gives us 2x, and 2x and 9x have a difference of 7, so that's the right one. We need a negative 3, but we need to get positive 7x, so that means we need positive 9x minus 2x, so our signs go that way around. Solving a quadratic, if we solve this, 3x would equal positive 1, which means x is equal to positive 1 over 3. Or for this equation, 2x would equal negative 3 if this was equal to 0, which means x would equal negative 3 over 2. So we've got two solutions. X is either positive 1/3 or negative 3/2. Okay. The question is asking us just for the x values, so we don't need to go back and find any y values. It's just asking us for the x values of the 2 points where those graphs intersect. So we've done that question, we've completed it. So if you had this in your exam, to get achieved, you have to either form an equation by equating your equations and simplifying to a quadratic. So these first two lines, okay, would get you achieved. Or something, perhaps when you are simplifying, maybe something goes wrong, but you can consistently factorize what you have for your quadratic. That will give you achieved, even if you don't have this quadratic. Okay. For merit, you need a consistent solution to your to your quadratic equation. So again, you've maybe made an error when you've done some rearranging, but you have been able to factorize and solve it. You can get merit, even though you won't have these solutions. Or you get the correct quadratic and you correctly factorize it. So you get down to this bit here, okay, but you don't solve it. And then for excellence, you need the two correct solutions. Okay. This next question is also from the 2019 paper. So this one says the equation of the straight line passing through the points -5, -10, and 9, 11 is given by qy equals px plus 5. Using algebraic methods, find the values of the numbers p and q. I think that's actually supposed to say variables. That's right. So we have 2 points on the graph, and you'll know that whenever we write points on a graph, we have an x value and a y value. So we've got an x value and a y value here that go together, and an x value and a y value here that go together. So we're going to use those to write our two equations. And our unknowns are actually the q and the p, not the x and the y, because we're going to know what they are here. So if we take our first point, x is -5, y is -10. So this means that y is -10. So we've got q times -10, which we would write as -10q, is equal to p times x. Well, x is -5, so p times -5, -5p plus 5. That's our first equation. And then we're going to do exactly the same thing, but with our second set of coordinates. So 11 is the y, so q times 11, or 11q, is equal to p times x, so 9 times p, and plus 5. Okay, two equations. Using our substitution method, we need to find one of the equations that we can divide through because we've got coefficients of all of our variables, and then we need to make it the subject. So this one doesn't work, we've got 11 and 9, but we can see that we can divide this through by 5, which will give us p, or negative p. So if we divide through by -5, then we'll end up with positive p. Doesn't matter, we can always rearrange. So if we divide through by -5, we get -10q divided by -5 is going to give us positive 2q. Sorry, I won't make that an equal sign, that's just 2 dots. Is equal to -5p divided by -5 is p, and then 5 divided by -5 is -1. Right, making p the subject, we move our -1 to the other side, so we have 2q plus 1 is equal to p. So now we're going to substitute into our second equation. Instead of having this p here, we're going to replace it by 2q plus 1 because we know that they hold the same value. So we'll do it over here, I think. 11q is equal to 9 lots of p, but p is equal to 2q plus 1 plus 5. So expanding out, 11q is equal to 18q plus 9 plus 5. So 11q is 18q plus 14. Bringing our q's to the left-hand side, 11q minus 18q is -7q, is equal to 14. And so q is 14 divided by -7, which is -2. So there's our first solution. We're asked to find both p and q, so we can go back to this. So we know that p is equal to 2q plus 1, and we now know that q is -2. So we've got -4 plus 1, which is -3. So p is equal to -3, and q is equal to -2. Both solutions. So for this question, to get achieved, you form both equations, or you consistently combine your equations into one variable. So maybe you did something wrong. Maybe you accidentally did x and y around the wrong way, but you can consistently combine them into one equation. So that's sort of like this. Then that will give you achieved. And if you keep going with that error and you get a consistent solution for one variable, then you can get achieved. For merit, you can correctly find the value of p or q, so one or the other. And for excellence, you get some solutions for both. Okay, you could potentially solve, or you can actually solve this question by thinking about the gradient, because you've got a linear line, so you know you've got your graph. You've got -5, -10, and 9, 11. You could calculate the gradient by looking at rise over run for that line and use that in order to solve for p and q. So if you do that, finding the gradient will get you achieved. Or testing the values in the equation. So when you get the gradient, you can test the values in order to solve the equation. And if you do that, you test one of them, then you can get merit. Okay, but seeing as we were looking at simultaneous equations today, this is actually the way I would solve it. So one final question for today. So this one is from the 2018 paper. It's quite a lot of information, so we'll read through it and then we'll see if we can make sense of all of this stuff. So we've got George and Leo. They're organising 27 people into 2 groups to go to a sports game. The tickets are $20 for students and $30 for adults. Half of George's group are students, 2/3 of Leo's group are students. The cost of tickets for the 27 people is $650. The question is asking how many students are in Leo's group. We need to obviously use algebra paper to solve the question. So we've got 27 people, we've got students, and we've got adults, and then we've got George's group, and we've got Leo's group. So there's lots going on. Where to start? Very good question. Okay. We know that there are 27 people. We know that tickets are $20 for students, $30 for adults, and we know that it's cost them $650 in total for the cost of the tickets. So using those bits of information, we can actually find out how many adults and how many students we've got. Once we know that, then we can tackle this information with George's and Leo's group. Okay, so we want to find, first of all, how many adults and how many students we have in total. So if A is the number of adults, and you can use S for the number of students. I'm not going to do that because I find that S's and 5s can get confused quite easily. So we're going to take T as the number of students. Okay, you could use X and Y if you want to. It's completely up to you. We're just going to use A and T. So we know that there are 27 people in total. So the number of adults and the number of students has to equal 27. And we know that they spent $650. So $20 for the students and $30 for the adults gives us the 650. So 20 times the number of students plus 30 times the number of adults would get our $650. Okay, 1, 2. This one is nice and easy to rearrange. So if we rearrange the first equation, we can get the number of adults is 27 minus the number of students. Right, and now we can substitute. So 27 minus T is actually the same as A. So we're going to replace our A with 27 minus T. So 20T plus 30 times 27 minus T is equal to 650. Okay, just replaced it. So 20T plus 30 times 27. So if you weren't sure, this way, you could do your 30 times 27, because remember you're not allowed a calculator. So that would be zeros, carry on your zeros, we get 21, and 3 times 2 is 6, times 2 is 8. So plus 810 minus 30T is equal to 650. If you can do 27 times 30, then that's fine, but you can do that. So simplifying, we've got 20T minus 30T, it's going to give us negative 10T. 650 minus 810. So 650 minus 810, 650, 750 would give us 100 plus another 50 plus another 10. So we've got negative 160. So T would be negative 160 divided by negative 10, which will give you a positive 16. Okay. So we know we've got 16 students. Adults is 27 minus 16. Okay, so we need 11 in order for that to work. So we've got 11 adults and 16 students. From here, we just go back to the question. We know that half of George's group of students and 2/3 of Leo's group of students. So we now need to write 2 more equations and solve them in order to actually answer the question, how many students are in Leo's group? So there are 16 students in total. We know that half of George's group are students. Okay, I'm just trying to rearrange this so you can actually see all the stuff that you need to see. So half of George's group. So let's say that G is a number in George's group. and then L can be the number in Leo's group. We've got half of the people in George's group plus 2/3 of the people in Leo's group are students, so that means that they would have to add to 16. Okay. For your second equation, you've got two options. We still know that the number of people in George's group and the number of people in Leo's group have to still equal 27. So you could use that as your second equation. Or you could say if half of George's group are students, then half of George's group have to be adults. If 2/3 of Leo's group are students, then 1/3 of Leo's group need to be adults, so they would have to add to 11. Okay, so you can have either of these equations. I would pick this one because it doesn't have fractions, so it looks a little bit more user-friendly. Okay, but that is an option if you wanted to use that one, that would be fine. So we've got our two equations. Again, we've got another two options. We can obviously make this, we can rearrange this to make either G or L the subject of this equation quite easily. And we've got these fractions in here. So we could do that and substitute into here and solve, and that would be fine. The other way to do it is to make it a little bit easier for us. We can still rearrange this to make G the subject. If we double this equation, then this ends up being a whole number. Okay, and now when we do that, we can rearrange this to make G the subject and rearrange this to make G the subject. And then we have something similar to the first example where we can just make things equal to each other because they're both equal to G and solve from there. So I'm going to solve it that way and I'll sort of show you how that works. But you could rearrange this, make G the subject, and then substitute into this without changing it. It just means that you'll have to manipulate fractions a little more. Okay, so if we have equation 1 and we double it, we get half G times 2 is just G. 2/3 L times 2 is 4/3 L, and 16 times 2 is 32. And we've still got our G plus L is 27. If we rearrange this, we get G is equal to 32 minus 4/3 L. And then rearranging our second equation, we get G is equal to 27 minus L. So if G is equal to this and G is equal to this, then 32 minus 4/3 L must be equal to 27 minus L. Okay, now I've only got L to solve for. So put all the L's on one side of the equation and the numbers on the other. So if we take our 32 to the other side, 27 minus 32 is going to give us negative 5. We've got negative 4/3 and we add an L, so we're adding 3/3. We've got negative 1/3 L is equal to negative 5. Okay, so that means if we multiply all of this by 3, we just get negative L and negative 15 on the other side, which means L must be equal to positive 15. Going back to the question, how many students are in Leo's group? So this equation was for students. We've got L is the number in Leo's group, so we've got 15. All right, in Leo's group. We could find George's group, but we don't need to worry about that. Okay. Sorry, we've got 15 people in Leo's group. We still need to find the number of students. So we know that 2/3 of Leo's group are students. So 2/3 of 15 is 10. Okay, so 15 people in Leo's group overall. 2/3 of those are students, so 10 students in Leo's group. Okay, so that was quite a lot of work. We essentially ended up with 2 lots of simultaneous equations to solve. So you might find that this question was more difficult than the ones from the 2019 paper. Sometimes that happens. Some of you might have found this easier than the graphing ones. It just depends what kind of makes sense to you. For this question, if you get 2 equations correct, so we're really looking at these first 2 equations, if you can write those 2, you get achieved. Or if you have 1 equation correct and 1 variable eliminated, then you can get achieved. So I'm going to redo this question on Monday with you and show you how it would work with the elimination method. We have technically eliminated a variable here, so you will get achieved if you kind of got this far, even if one of your equations is wrong. For merit, you get your first pair of simultaneous equations and you solve them for both t is equal to 16 and a is equal to 11. Or you use algebra to find the number of people in either person's group, so one or the other. Or you have an error in your equations, but you consistently solve them to find a and t, and you also have to set up the next pair. So you have to set them up, you don't have to solve them. That would give you merit. For excellence, you get your correct solution of 10 students with obviously some valid algebraic working in order to show how you got there. Okay, so some, it's not just with simultaneous equations, but some excellence questions you'll find harder than others. Typically in a paper, there are about 6 excellence questions, and you'd normally need to get 3 of those correct to get excellence overall. So if you think you have a particularly difficult excellence question, you've kind of done some stuff but you're a little bit stuck, then leave it and come back to it and go and do some of the other questions. You might find them more accessible to you and you can get some marks from those, and then at the end you can come back and spend some time working on that question that you might have found a little bit more tricky, but just making sure that you bear that in mind. You don't want to spend a huge amount of time on a difficult question like this. That then means you don't have time to finish off the other questions that you might feel more comfortable with that come up later in the paper. Okay, so just thinking about that exam technique is quite useful. And so on Monday, I'll just throw up my timetable to have a look at. On Monday, we're still looking at simultaneous equations, so we'll have more of this fun, but we'll be focusing on using the elimination method. So as I said at the beginning of our session today, substitution method is great. Sometimes it's really easy and sometimes it can be quite fast. But if you have some difficult equations where it's kind of hard to divide through, then the elimination method might actually be a lot easier for you. So making sure that we've got both of those methods in our toolkit is really valuable. So Monday we will look at elimination method, and then next Wednesday we're going to look at some problem solving sort of style questions, and I'll go through some of the questions from the 2019 and 18 papers that I haven't covered in previous lessons, just so you can feel for some of those things that might not necessarily have fitted as nicely into some of these categories. So if you've got any questions that you want me to go through in the Thursday session, then just send it through on an email. Tomorrow I'll be here at 5:30. I think I've got 3 questions at the moment that I'll go through from previous papers with you guys, and they're all questions based on content that was sort of covered recently. But if you do come across anything and you're a little bit stuck, then email it through to me and I'll happily go through that tomorrow if I get it in time. Thanks for watching. I hope this was really helpful. If you like it, please share with friends and tell them about Maths with Corinne. Share the link with them. If you've got any things you want me to go through, as I said, just email me. And if you have any feedback about stuff that you found really helpful, then let me know. That would be awesome. Otherwise, have a good evening. See some of you tomorrow for those questions. Otherwise, hopefully Monday when we look at the elimination